So we've looked at the theory behind calculating the angle between two planes in three-dimensional space. Got a couple of exercises here for you. What I'm going to do is I'm going to show you a couple of questions. Pause the video, have a crack at them, and then come back and check your answers against the working I'm going to show you here. Here you go. So just two questions on it about finding the angle between planes. The only difference is in the second one I'm a bit more specific about which of the angles I'm after. And you'll see exactly what I mean when you're doing them. So pause the video and have a ping at those. So the first question, I want to find the angle between the planes with these given equations. Now remember the theory behind it. The angle between the two planes is the equivalent to the angle between the two normals of the plane. So the first thing I have to calculate is the normals of both planes. Then I have to use the scalar product and the fact that cos theta is equal to A dot B over magnitude of A magnitude of B to get my angle. So let's imagine I'm going to get my two vectors, my A and my B, the normals to the plane. So A is going to be the normal to this plane here. And just by inspection I can say it's 1, 1, negative 4. And B is going to be the normal to this plane here. And again, just inspect the equation and look. And I can tell it's 2, negative 3, 4. So I now need to do, firstly, the dot product, A dot B. So what that's going to give me is 2 minus 3 minus 16. So that's going to then be the equivalent of minus 17. I then look for the magnitude of A. So that's going to be given by the square root of 1 squared plus 1 squared plus the negative 4 squared. So that's going to give me the square root of 16 plus 1, so square root of 18. Then the magnitude of B for that one, that's going to give me the square root of 2 squared plus the negative 3 squared plus 4 squared. So if I look at that, that's 4 plus 9 plus 16. 9 plus 16 is 25 plus 4 gives me the square root of 29. So what I now do is I plug all of that together and I can say find, so I know that cos theta is equal to A dot B over magnitude of A, magnitude of B. So then I can say find, so that equals negative 17 over root 18 root 29. So from that I can say find, so theta is inverse cos of that, so theta is cos minus 1 of the negative 17 over root 18 root 29. And when I calculate that and work it through, I get 138.07 points there, 079, and it continues. So that would be the equivalent of 138.1 degrees. Now that's an obtuse angle. Essentially what this means is if this is my vector representing the plane A, and this is the vector representing the plane B, all that it's done is imagined that I've gone a bit further along here with B, and it's calculated the obtuse angle here between the two planes. So if I was to be asked for the angle between the two planes and look at the acute angle, I'd have to do 180, take away the angle that we've already calculated. So I'd have to do 180, take away 138.1 degrees. What that would then give me is 41.9 degrees for the acute angle between the two planes. So we've got two possibles there that we can get, so just look out in case the question asks you for a specific one and a specific angle in relation to both of the planes. Now this second question specifically asks you for that acute angle. So if we were to calculate through and end up with the obtuse angle we had, we'd have to use that final step that we did a minute ago and do 180, take away that angle in order to get the acute angle. Steps are still the same though as we would before. Get our two normals, A, so I'm going to make that the normal of this first plane here. So 2, negative 1, 0. And the second plane, B, this angle, this plane here, 1, 1, 1. Then I have to do the three parts of it. So first thing I do is the scalar product, A dot B. So what that's going to give me is 2 minus 1 plus 0. So that's just going to give me 1, which is quite nice. I then do my magnitude of A. It's going to be the square root of 2 squared plus the negative 1 squared plus 0 squared. It's going to give me root 5. Magnitude of B, square root of 1 squared plus 1 squared plus 1 squared. That's going to be the square root of 3. Then we just plug it in the formula. We know we're going to use cos theta is equal to A dot B over magnitude A, magnitude of B. Plug in the values. We know then that cos theta is equal to 1 over root 5 root 3. From that, theta is equal to cos minus 1 of this, so cos minus 1 of 1 over root 5 root 3. And if I do that and calculate through, what I end up getting is that theta is equal to 75.036. So it's equal to 75 degrees. So it's quite nice we've actually got the acute angle. If we'd had the negative of that, so cos minus 1 of negative 1 over root 5 root 3, what I'd have ended up with is 105 degrees, and I would then have had to do 180, take away that 105 in order to get the 75 degrees, i.e. the acute angle that we would be after in this question with the way it's asked. So calculating the angle between the two planes is actually fairly straightforward as long as we can remember those steps in the properties, i.e. calculate the angle between the normals to the two plane, and that represents the equivalent of the angle between the two planes themselves. Once we know that and remember it, it's plain sailing from there.